We're talking about triangles. We're talking a lot about triangles. I really like triangles because triangles are the building block for everything else we do in geometry. I know I said that about a few things, but triangles are one of the many building blocks from everything else. Every shape except for a circle comes from triangles. Every shape except for every shape that we'll talk about here, except for circles, comes from the triangle. And we're going to keep referencing back to triangles as we go through them.
What's a circle?
Oval.
Ooh. Okay.
Yeah.
Or an oval.
A line.
What about a pentagon?
We won't talk about ovals in here, though. So.
Wait, hold on.
Okay,
Weird
so.
question. What is the weirdest shape of a name or whatever? Name of a shape. Sorry.
Polytetrahedron.
What?
Wasn't that one?
That's like one of those ones that walks on.
Polytetrahedron. It's like the three-dimensional polygon.
Say another one.
Yeah, you already get one. So anyway,
Two.
chapter 4 is about triangles, and they're really important. Okay, really, really important. And you guys noticed a few things about triangles anyway, right? Okay, just from normal, real-world things. Okay, so you know a triangle is a shape with three sides. We'll call it a polygon with three sides. Okay, that's our fancy word, polygon. It's just our name for a shape. A polygon with three sides. Now we can name this shape over here on the side. We can name this triangle in a couple different ways. So one way we can name it is we can write out the word triangle. So just like with lines, rays, point, plane, we can write it out. We can write out triangle, and then you list the points of the triangle. A, B, C. We have point A, point B, point C. So we list the points of the triangle. Some of you might be wondering, Mr. Gossel, can we put the points in a different order? Like, could we say triangle CAB? You sure betcha. Okay, our rule with polygons is you have to be able to go in order. But the thing with a triangle is no matter which way you go and which points you go, and it doesn't matter because they're going to be in order. So as long as you name the 3 points of the triangle, that's all that matters because then you name the triangle. So it could be triangle ABC, CAB, BCA, BAC. There's many combinations. Questions on that? Okay, there's exactly 6 combinations actually. Or you can draw this little triangle logo and call it triangle ABC or CAB, BAC, all of those different things. So draw on a little triangle there. Unless the rains aren't after us, we forget.
Oh.
So draw on a triangle and make it triangle ABC. So just like with a line or a ray, we had many versions of that shape. You guys remember that? Okay, we had many versions of that shape. Max, keep it away. Thank you. Okay, we're doing the same thing with a triangle. You have a mini triangle and say triangle ABC. So we can classify the triangles by their sides. We can classify the triangles, call them different things based on what their sides are and the length of their sides specifically. We'll deal with the length of their sides. Sorry. So a scalene triangle, is a triangle that has no congruent sides or 0 congruent sides. What's congruent mean? Yeah, they have the same length, they're equal in length. So this is saying that none of the sides are the same length. If it's scalene, no 2 sides are the same length. All 3 sides are different lengths. So like one side's 5, one's 8, and one's 11 or something. Okay, as long as they're different, that's what matters. Isosceles triangle, it has at least 2 congruent sides. At least 2 congruent sides. It can have 3, but it has at least 2 congruent sides. And you see these little tick marks here? That means these segments or these sides are congruent. Very good. And in an isosceles triangle, we call these 2 congruent sides legs. And we call the third one, if it's not congruent, a base.
So like
a thigh and two legs?
Yeah.
We call it a base and the two legs of the isosceles triangle. And we say that the angles opposite the congruent sides are adjacent. So because this angle is opposite the side, and this angle is opposite the side, they're congruent. So the angles opposite those two congruent sides are congruent as well. And our last one's an equilateral triangle. It has three congruent sides. All sides are congruent in an equilateral triangle. If you kind of look at the word equilateral, what kind of word do we see at the front of there?
Equal.
It kind of looks like equal, okay? And lateral means to the side. Okay, lateral means to the side. Say two things are lateral, that means they're side by side. Or if you have a lateral pass in a sport, okay, it's to your side. It's not forward, it's not backwards, it's to the side. It's a lateral. Okay? So lateral just means to the side. So this just means equal sides. All three are congruent. And so just like the angles opposite the congruent sides here are congruent, the same thing will be the case here. So an equilateral triangle, all three angles will be the same. Questions on this one, on the sides part? Okay, right below this, we're going to classify triangles not only by their sides, but also by their angles. So we can classify triangles by their angles as well. And we'll have 4 different classifications for this one. And this is why we went over those angle reviews at the beginning of class, where I had you describe the acute angles, obtuse angle, right angle. We're going to use them. An acute triangle has 3 acute angles. It has 3 acute angles. All the angles are acute. Okay, and as we said earlier, an acute angle is something that is greater than 0, but less than 90 degrees. So it's between 0 and 90 degrees. So we're saying x is between 0 and 90 degrees.
That's an X.
Yeah, this is an x.
Wait,
I need
do you
it.
like repeat it?
I'll rewrite it.
Mine.
I'll rewrite it.
0 and 90 degrees. Oh, 0 degrees.
Is that better?
Alright, so between 0 and 90.
Yeah,
That's
between. Okay, you can write between 0 and 92. If that helps you remember, if that's easier for you, you can write between 0 and 90. A right triangle has 1 right angle, exactly 1 right angle. And it's good to note, it's important to note, bless you, unless reading on F, lest you forget, that the other 2 angles, the other 2 are acute. The other 2 angles are acute. An obtuse triangle has 1 obtuse angle.
Would the other two be acute too?
They would be, very good. The other 2 in this would be acute as well. And an obtuse is between what and what?
180.
Yeah, between 90 and 180, very good. Equiangular, what do we think that one's going to have?
3.
3 congruent angles. Equa, equal, angular, angle, equal angles. All 3 angles are congruent.
Would these be acute?
They would all be acute. Very good. And they're going to be, we'll say even furthermore, they're 60 degrees each. Each angle will be exactly 60 degrees. We'll talk more in depth on that later today. Questions on this section? Talking about classifying triangles by their angles. So not only by their sides, but also by their angles. Okay, moving on to the right beneath this. We need to classify these triangles by their sides and by their angles. So this first one, we need to look at the sides, we need to look at the angles, and we need to say, okay, how many congruent sides does this have, if any, and what kind of angles does this one have? Kylie, what kind of triangle did you say that you think this was? Obtuse. Okay, why do you say obtuse? Okay, so these two at the bottom are acute, and this one at the top is in fact an obtuse angle. So it's an obtuse triangle because it has an obtuse angle. Well, it's obtuse by the angles, so that would be the B part, classifying it by the angles. But for the A, classifying it by the sides, Grace, you think it's what? Scalene. Why do you say scalene? Because it looks exactly like the scalene triangle we had earlier, okay? Are any of these three sides congruent to each other? Are any two the same size length? No, they're all different lengths. So by definition, it's scalene from the sides, and by the angles, it's obtuse. So it's a scalene and obtuse triangle. It's both. It's both of those two. It can be one of the ones from the angles, and it can be one of the ones from the sides. So from the sides, it's scalene, because no two sides are congruent. From the angles, it's obtuse, because there's an obtuse angle. Let's try the second one. Okay, based on our sides, let's start with sides. How many do we see congruent? 3, okay? Which of these triangles says that all 3 sides are congruent? Equilateral. So that means it's an equilateral triangle. What did we say was true about the angles of an equilateral triangle? They're all congruent. They all have the same measure. They're equal measure. Okay? That means it's also equal angular. And they're all 60 degrees. Very good. So this second triangle would be equilateral and equal angular. So based on the sides, all 3 sides are the same length. They're congruent. So it's equilateral. Based on the angles, all 3 angles are the same, thus making it equal angular. Not the whole packet, no. Okay, this third one, what kind of triangle is this? Let's say based on the sides. Based on the sides, let's start with the sides. Okay, so we're saying that 2 of the sides are the same length? Okay, so those of you saying the 2 sides are the same, which ones are you thinking are the same? The left, bottom, or the kind of diagonal one? Okay, I don't think they're the same. Okay, and so if no 2 sides are the same length, what kind of triangle is this? Scalene, very good.
Would this be right?
And then based upon the angles, why do you think it's a right triangle, Nathan?
Because it has a little chair-looking thing at the bottom.
It has this little chair-looking thing, that box, which tells us it's a what kind of angle? A 90-degree angle or a right angle. So if it has a 90-degree angle or a right angle, it is automatically a right triangle. Going on to number 4. Looking at the sides. How many sides are congruent? 2. Which of these triangles, which of those 3 from the sides, the top ones, has 2 sides congruent? Isosceles, very good. So what kind of triangle do you think this is based upon angles? Okay, why do you say acute? You just think it's good looking, so you're saying it's a cute one? They're all acute angles, thus making it an acute triangle. Okay, Process of elimination, we haven't had one yet, so we probably have one there. Okay, good idea. Question on this first page of notes. Look at the second page, please. Thank you. I said page. So, excuse me. Second page. Please and thank you. Yeah, second page. Watch. Okay. So at the top of this one, we need to sketch an example of this type of triangle described and mark it whether it's and mark whatever information we have known. So that means like if angles are congruent, mark those. If sides are congruent, mark those. That kind of stuff. And if you can't draw it, write not possible. I want you guys to try this real quick. Okay, I want you guys to try these. Okay, I want you to try drawing some of these. Go ahead and try that. Please and thank you.
Why are you smiling?
Just don't go away.
I mean, yes.
Hey, I want you guys to try these. Please and thank
I'm
you.
trying.
So I want you to draw these. So on this one, I want you to draw an isosceles right triangle and label what you know. Or if it's not possible to have an isosceles right triangle, say right not possible. Okay. Can't hit. That one is possible. You can't have an isosceles right triangle.
And we can't have options.
I put this one not possible.
Does somebody want to come up and draw this first one? Kylie, go ahead. It's all purple right now.
I'm not bad at drawing, so honestly, this will be interesting.
I mean, as you can tell from direct class, I'm really the best artist in the school.
Yes.
See?
Wait,
Disagree.
number one. Wait, what does isosceles mean? Sure. These two are congruent. You just
So
don't
mark them.
the line.
No.
That's pair. That way.
No, what are you doing?
Let's go over here. Just do one.
Tyler.
So we do with the dash. Okay, bet. Alright, this would be an isosceles right triangle. It helps that Kylie said these two are congruent, we just don't know it, okay? If you mark them congruent, then we do know it. So even if your picture's a little off, that's the way you can help and say, oh, well, they're congruent now. So this is a right angle, even if it might not look like it. She said it was, so it is. These are congruent sides, even if it might not look at it, she said it was, so they are. Very good, isosceles, two congruent sides or more. Right angle, because it's a right triangle. Very good. Anybody have number 2 they want to do? Next.
No, I want to.
shooting
Oh
six.
no.
I've also got 9:30.
Oh.
Upstairs? Yeah, I know.
I'd practice.
You started Snapchat, and then it says upstairs. I saw you were sleeping out.
Oh, botch.
Why do you keep doing that?
Means mistake.
Oh.
Obtuse.
Okay. Thank you. So, is this your obtuse angle?
It's supposed to be a flatter line.
This is supposed to be a flatter line?
No, the right, that's supposed to be further out.
Like this way?
No, oh.
Who's redrawing?
Yeah, I get it.
It's trying.
Yeah.
That's better.
Pretty good.
That's 10 out of 10.
Okay, hey, I agree with this one. Okay? Scalene because all three sides are different lengths, and it's obtuse because this is an obtuse angle. Very good. Okay? Go ahead. Alicia's gonna do number 3.
It's gray. No, not my color.
You look.
Yeah.
And then
This is all lowercase.
Okay, so
That
Alicia,
is
why?
lowercase.
Voice it off. Alicia, why is this not possible?
Because you can't have a right equilateral triangle.
Okay, equilateral means that all angles would end up being what?
Equal.
Okay, all angles would be equal. Means all angles would be 60 because an equilateral triangle is also equiangular. Equilateral triangle also has all the angles congruent. But you can't have a right triangle that's also equilateral because if you have a right triangle, that means one of the measures is 90. If one of the measures is 90, can all of them also be 60? No, it's not possible that they're all 60 but one of them's 90. That doesn't work. So it's not possible. You can't do it. Anybody have this last one, number 4 they want to do? Next.
Yo, man.
Let me guess, Gray?
No, I want to do.
Gray.
Oh, how'd I guess?
I had a feeling. When do we get back there? No, you need to figure something else out.
Dude, that's not me. Marley. Marley. Marley, that's usually me.
I agree. Voice is off, everybody. Please and thank you. Okay, so this is an acute angle, acute triangle, excuse me, it's a acute triangle because it's a good looking one. And it has all acute angles. All the 3 angles are acute. It's also isosceles because these 2 sides are the same length. They're congruent. Very good. Questions on these 4?
No, sir.
Okay. Right beneath it, we have our triangle sum theorem we're going to talk about.
Wait, Mr. Carlson.
Yeah.
Okay, so my cute isosceles can be all 3 of them are congruent.
Yeah. Isosceles is at least 2, so technically yes, it could be. So typically we call the isosceles triangle only 2, but it can be at least 2. So technically it'd be accurate. Because if it's all 3, then we go more specific and say it's equilateral. So the triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. Who can tell me what sum means?
They add up.
They add up to. Very good. So the 3 angles in a triangle, the 3 interior inside angles of a triangle add up to 180. So that means this angle, and this angle all add up to 180. So measure angle A, B, and C all add up to 180 degrees. Every time, regardless of your triangle. If it's a triangle, all 3 angles have to add up to 180. Not possible otherwise. Okay. So on these, you need to find the missing measure and classify each triangle. So if we have 2 angles, how could we find our 3rd one? Gracie.
Add 42 and 52 and then subtract it from.
Ah, great. Add 42 and 52 and subtract it from 180. What is 42 plus 52? Anybody know?
Crazy?
94. 94.
That's what I meant. I had it like.
Okay.
Killed it.
Now we need to do 180 minus 94.
Oh wait, I calculator. It's 86 or something.
It is 86 degrees.
Wait, what's the line down below for?
To classify the type of triangle. Let's talk about this of how this worked. Okay? So we said all three angles have to add up to 180. So that means 42 plus 52 plus whatever angle C is has to add up to 180. So if we take the total, subtract the two we know, we'll find the one we don't. Very good, Gracie. So now, if we know these three angle measures, 42 degrees, 52 degrees, 86 degrees, what kind of triangle do we have based upon the angles? Faith? No, it'd be one of those four, the angle ones. Are they all acute angles?
Yeah.
Okay, then yes, it would be acute. Very good.
I said that first. When will we know if we can
It'll tell you to. So here we can only classify by, well, using what we know, we can only classify by the angle. So if we know these two angles, A and B here, how could we find angle C? Raise your hand if you can tell me how we would find that. Raise your hand to tell me how we would find that. Okay, Nick.
Do the same thing you did for number 1.
Okay, so that is adding these two and getting, and doing what with this 90.
Subtracting it from 180.
And what do we get? 90 degrees, okay? So if this is 45 degrees, 45 degrees, and 90 degrees, what kind of triangle do we have?
Right.
A right triangle, because it has a right angle. Very good.
Where's the right triangle? Like the little triangle thing?
No, you just say acute right. Yep. Dope. Turn. Cash money. Yeah.
Please stop. That's flat.
Let's get to
Roll up. Oh my god.
Yo.
You're making us waste time. Come on.
Okay. So we also have a corollary. Make sure I spell this one right. Okay. Yeah. Corollary to a theorem. Has anybody heard of the word correlate or correlated, or like these two things correlate?
I've heard it, but
Okay.
I never respond.
Anybody know what they mean? That means, yeah. They're similar, okay? They're kind of, they go with each other. Okay, they're related in some way. Okay? So if you think correlate, they're similar, they kind of go with each other. So a corollary to a theorem kind of has the same start of the words, correlate, corollary. Is it a correlate? Corollary is a statement that may be proved easily using a theorem, or it follows a theorem. So it jumped out of my hand. So we have a theorem, and then a corollary to a theorem is saying, oh, because of that theorem, this just follows right after. Yes, Nick?
Take out drink.
You may have trouble grabbing one from the water fountain. But yes, go ahead.
Wow.
So, corollary to the triangle sum theorem, the acute angles of a right triangle are complementary.
Oh.
Can I grab a bathroom?
The acute angles of a right triangle are complementary, meaning they're friendly with each other, remember? Okay? That's the poster I have back there. They complement each other, they add up to 90 degrees. The acute angles of a right triangle are complementary. So angle A and angle B, the acute angles of this right triangle here, add up to 90 degrees. 100% of the time. And here's why. If one angle is 90 in a right triangle all the time, and all three angles add up to 180, well, what do the others have to add up to? 90. Okay? Let's talk through that real quick again. So if the whole thing adds up to 180, and it's a right triangle, so we take away 90 off the bat, there are 90 degrees left for the other two to add up to. So they have to add up to 90. There's no other way. Questions on that? Turn. Okay, so at the bottom of this page, we can solve for x and find each of the angle measures, so that way we can classify this angle.
We do.
I hate that.
Okay, hey, so what do you say the equation is going to equal?
I guess the
Okay, why'd you guess 180? It looks like it should equal 180. Max, Max, what do you think?
Because triangles always equal 180.
The sum of the angles of a triangle always adds up to 180, okay? So we're going to add things up equal to 180. Who can tell me what we'll add to 180? Kylie. Kylie, where did you get those three things from? From the triangle. They're each angle of the triangle. All three angles of the triangle. All three angles of the triangle add up to 180. So we'll take all three angles of the triangle and add it up to 180. So we say, hey, here, that's the first angle. This is the second angle. And this is the third angle. And we add them up. And I heard somebody say, what are we going to have to do here since they're all on the same side of that equal sign? Combine like terms. Add them up, okay? So what? Who can tell me, who can identify like terms on this side? Okay, Gracie. X, 2x, and x. Very good. They all have the same variable. X is the same power of 1. They add up to 4x. Very good. Who can tell me the other like terms on this one? 20 and negative 40. Okay, and what do those combine to? Negative 20. You have a negative 40 and a positive 20. So they combine to a negative 20. And this 180 over here is just chilling. Okay? Randall, how would we solve this one now?
I don't know.
Okay, use your math brain. How would we solve this one now? 4x minus 20 is equal to 180.
You add 20.
Very good. We'll add 20. We want to get it away from the x's, so we'll do the opposite. Because negative 20 plus 20 is 0. So 4x is equal to what? 200. Okay? And now, how would we solve this one, Julia? Divide by 4. Very good. 4x divided by 4 is just x. And 200 divided by 4 is 50. So x is 50. Okay. First part, solve for x. We did that. Yeet. Okay? And find each of the angle measures.
Oh, I can do that.
How can we do that?
Beat it. I got this.
Okay, Gracie.
You do 50 plus 20.
Okay, so we plug it in and we get 50 plus 20.
70.
So this one's 70 degrees.
Yep.
Dope.
And 100.
Okay, so 50 times 2, which is 100, minus 40, which is 60 degrees. Okay, and what's this last one? Just 50 degrees, right? It's given to us.
I know what this thing is.
It's just x. And if we check, these would add up to 180. And then we need to classify the triangle. So what kind of triangle do we have, Alicia? It is a scalene, but based on the angles, which is what we're doing, it's a cube. Very good. Okay, it's a good-looking triangle. It's a cute one. Questions on that one, class?
No, sir. Class. This has all of
Go to the job.
mathematics.
Okay, flip the page, please, and thank you.
Onto the Spanish mix.
Voice back off, please, and thank you. Okay, so we have two different types of angles. Okay, we have two different types of angles for these triangles. We have interior angles. Those are the ones we were just talking about. Interior means what? Inside, okay? So it's going to be the angles inside the triangle. Okay, the ones inside. And we know something special about these. What do we know about the three interior angles of a triangle? They what? They're inside, very good. And they add to 180. So they're inside the triangle and they add to 180. Very good. So we have interior angles and we also have exterior. What's exterior mean?
Outside.
Outside, okay? Interior and outerior. Okay? It's a joke. It's interior, exterior. Anyway. So, interior, exterior.
There's a lot of them.
Angles that form linear pairs with interior angles if we extend the sides out. So we have this triangle, and then we extend this like triangle here. Ooh, that was rough. And then we extend the sides out, and we get those. Okay? So we have quite a few different ones here. What's a linear pair? They by each other, they make a straight line, so they add up to 180. Okay, two angles that add up to 180 are supplementary.
I'm so smart right now.
I'm so smart right now, Mr. Fossil.
Oh,
Oh my god.
Okay.
amazing. This guy's a comic genius.
Bam. Okay. So for the exterior angles, voice back off, please and thank you.
Oh no, I'm good.
We would want this one, and this one. The reason why I chose those three, okay, the reason why I chose those three is because they're exterior, they're outside that, and we only want the ones, we do not want them to be on the same side. So notice here, I can also pick this one, but then this right here and this right here would be on the same side of the triangle, and we don't want that. We want the exterior angles to be on different sides of the triangle.
Wait, what about the one on the opposite side?
Ah, so what about if we did, are you saying like this one?
Oh no, move your hand to the green dot. Yep, that one.
This
Nope,
one?
go below,
This
yep.
one?
Uh-huh.
So does this form a linear pair
No.
with the interior angle? No, so
No.
we can't do that one either. That's from a linear pair. You can also do this red one, and if we were to extend this way, this red one as well. Because you can do the three reds or the three greens.
But we're not.
Okay? You can do either of them. But you can't mix them. Back that up, please. Okay. The exterior angles. One thing I want you to write here: exterior angles add to 360 degrees always. They will always add to 360, 100% of the time. Studies show that writing things help you remember it. Studies show that writing things helps you remember it. John. Bet.
I'm writing down, Carly.
Okay. This is not section 4-2, this is theorem 4-2, okay? So, exterior angles theorem. The measure of an exterior angle, so in this case, angle 1 is an exterior angle. Measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. We'll call them remote interior angles. What's remote mean? Well, think about a TV remote. Are you close to your TV generally when you use the remote?
Yes.
Okay, are you right next to it? No, there's some distance between you, right? That's why you use the remote. Okay, the TV might be there, but I might be over here, or I might be where William's at, or something like that, okay? So remote means you can do it from away. You can be away from it. Faith, head up, please, and thank you. And you can be away. So from angle 1, what two angles are away or not next to that angle in this triangle? A and B. Okay? Angle A and angle B are the ones away from angle 1. Angle C is right next to it.
C has one. Kennedy.
So,
I want to know why.
C is this angle.
Yeah.
1 is this angle.
Yeah.
So they're next to each other.
But
So
then why
C is
doesn't
not
A and B have a number of body points?
because we don't want to deal with these angles. This is angle B. This is angle A. So we're talking about 4 different angles. A, B, C, and 1. So remote interior angles, as it says right here, is an interior angle not adjacent or not next to the exterior angle. So the exterior angle here, these two are the remote interior, just like we have here with A and B. And we're saying the sum of those remote interior angles is equal to that exterior angle. We're going to use this real quick. It's right below this. Okay? We need to find the measure of angle B. We need to find this measure. This is, let me write these because these are tough to read. 5z minus 2. This is 145. And this is 2z.
Why did they put D? What?
Okay, if you write that as a T, the other one needs to be a T as well.
That was like an E. Looks like a P with a B.
Okay, well either way there's these. So let's continue on. How could we set this up using this knowledge we just learned? Using this remote exterior angles theorem, or the exterior angles theorem, how could we solve it? Well, we know all three exterior angles add up to 360. What else do we know? Okay, do we know the other two exterior angles? No, so that won't help us, okay? We do know an exterior angles, and we know two interior angles.
Oh, and then
Okay, what do you think?
145 stretch on the other side of what?
This one will add up to 180 with it?
180
Oh,
Okay,
minus
so
each.
Abby's saying that we can take 180 minus 145 and say this angle is 35 degrees, Abby? Okay, you could do that. How would that help us now? Okay, now we can add these three to 180. Okay, so we can set up 35 plus 5z minus 2 plus 2z is equal to 180. Okay, so what Abby did was the same thing we did earlier, add the three interior angles up to 180, but first, she found this interior angle and said, hey, that one's 35 because these are a linear pair. So we can solve it this way. Is there another way we can set this up, class?
No.
Yeah.
I'm asking, there probably is one. Okay, we could use this exterior angles theorem we just talked about and saying an exterior angle, 145, is equal to the sum of the two remote interior angles. So these two angles, 2z and 5z minus 2, are remote interior angles for this exterior angle. They're not next to it. So they add up to be equal to it. So we can either do the equation in the red or the equation in the blue.
You get the same answer.
You get the same answer.
Blue.
Which one's quicker?
Okay.
Red's quick.
Voice is off. Okay. We're going to do the red one together real quick. Okay? So 145 is equal to 2z plus 5z minus 2. What do we do first? Combine like terms. What do we get? 145 is equal to 7z minus 2. Okay, now what? 147 is equal to 7z. Z is equal to 21. So if Z is equal to 21, how can we find angle B now, William?
We have to divide 2 and 21.
You'd have to do what?
We have to divide the 21
By, this is a Z.
for z.
Okay, so Z is equal to 21, and we know angle B is 5Z minus 2. So if we know Z, could we plug it in?
Yeah, we have to plug it in.
I'll do that, okay? So 5 times 21 minus 2. Does anybody know what 5 times 21 is?
101. 105, I mean.
105. 5 times 20 is 100. 5 times 1 is 5. 100 plus 5 is 105. 105 minus 2. 103. So the measure of angle B is equal to 103.
I'm not okay.
I'm not okay. She's coffee.
Oh.
Save me. That's what I thought. I'm not getting 41.
We're gonna set this next one up. We're not gonna solve it. We're gonna set the next one up. Not gonna solve it. Okay. Voices off, please, and thank you. Find the measure of angle PRS. So this angle down here is 3x minus 8, and this angle is x plus 2, and this is the right angle, meaning the measure is 90 degrees. Very good. And we need to find PRS. We need to find this angle over here. Okay? How could we find that? Anybody? Can anybody tell me an equation we could use to solve this? Okay? Kennedy.
3x minus 8 plus
Okay? This is an exterior angle. What do we know about the exterior angles and the two remote interior angles?
Do I understand that?
They equal each other. So if this is equal to the sum of these, Voices back off, please. Pay attention up here. Okay, we're saying the exterior angle is equal to the sum of the two remote interior angles. So 90 and x plus 2 are interior angles that are away or not next to this exterior angle. So their sum, or adding them together, is equal to that exterior angle. Is that necessary?
I got this.
So we are not going to solve this equation. We are not going to solve that equation. I just wanted to send it out to you. Okay? We'll stop there for notes. We finished that section. You betcha. Chet, you betcha. You guys ever watch Fairly Odd Parents growing up? Fairly Odd Parents?
You have a new season and now there's a girl. You're gonna share the,
I don't like that.
yeah, it's horrible.
I'm gonna be a vet. I don't need numbers.
Are you
I'm kidding.
a vet?
Gracie. Come on, baby.
Class, voices off, please. I have an instruction for the worksheet.
You want that?
Class, voices off. Okay, everybody, look at number 9. Cross out number 9.
It's not possible, right?
Okay? Look at number 12. Cross out number 12. Go to the next page. 9 and 12. Go to the next page.
So much.
Look at 14. Cross out 14. Look at 21.
Don't do it.
Don't do it.
Do it.
Do not do 23 or 24
Holy crap, these are just going down. I like it. Keep it up.
or 26
Thank God.
or 28 or 31.
We have a story problem? No, I am not good at story problems. Just don't do that.
Hey, if you need to check which ones we did or not doing, look up at the board.
Oh, I got it.
Just don't do that.
What? Just draw on it.
I'll be gone Wednesday.
Wednesday and Friday?
Gracie.
Are you gone all week too?
Yes.
Okay, gotcha.
Yeah, okay.
Um,
If you don't like